Welcome to Study Loop.
This is chapter 37, problem number 14. We have a rocket that goes 95% of the speed of light, so it's going to be 0.95 c, right? The speed. Now in part A, we're given the proper length to be 2 meters in the frame of the ship. So L naught equals 2 meters. So in part A, we're asked to calculate a person on Earth. How tall would the pilot of that ship would appear to be for an observer on Earth. So then we have the length expansion formula goes like L naught over gamma factor. So all we need to do is actually calculate the L from here, provided that L naught is the proper length, well, the height of that person, right? So L naught, whatever gamma factor is going to be square root of 1 minus v squared over c squared. Let's put 2 meters here, square root of 1 minus 0.91 c squared over c squared. Now when we do the algebra, we find the height to be 0.83 meters to an observer on Earth. Still a little on the short side, right? So part B, this time we are given the height of this pilot based on an observer on Earth. So L equals 2 meters now. And what would be the proper height of this pilot in the frame of the ship that moves with this relative speed? Now, we're going to use the same formula, right? L equals L naught over gamma. This time, we're trying to calculate what L naught is. So L naught is going to be gamma times L. Gamma is going to be 1 over square root of 1 minus v squared over c squared. L is here. So 1 over square root of 1 minus 0.91 c squared over c squared. And L this time is 2 meters. So from here, we find L naught to be 4.82 meters. This is very, very unreasonable for a man's height, right? A human's height. So I think the tallest person ever there is on Earth is maybe 2.2 meters or something. So this is like twice of it. This is in the category of giants. Now in part C, we're asked what happens if the pilot's body is not oriented with the direction of the velocity of the ship. If it's so the previous measurements A and B were taken when his height was in the direction of the velocity of the ship. Now, what happens if he's standing up? Of course, if that's the case, then whatever is measured as his height on the frame of the Earth is going to be the same as whatever is measured. Well, we've been using letter L, so let's do that. Then this is what's going to happen. L is going to be equal to L naught. There is no length expansion in that case. So yes, we're going to be still measuring it to be 2 meters.